ladies and gents. Today we will be talking about arithmetic sequences.
Halt! What is this?
Could it be? You're super mathematician!
Yes, I'm Super Mathematician, and I'm here to save your video from becoming a total disaster. Now step back and watch your pro at his best. On today's video, we'll be discussing arithmetic sequences.
Cool! Where do we start?
Well, can you tell folks at home that are watching what a sequence is?
A sequence is any ordered list of numbers such as 15, 17, 19, and 21.
So, a list of numbers?
It's much more than that.
Nope, it's that simple. Now that we know that, can you tell the folks what an arithmetic sequence is?
It's a sequence in which there's a common difference between consecutive terms.
Correct. Now, can you give me an example?
Of course. Look at this example. 1.5, 2, 2.5, 3, 3.5. What's the common difference?
Well, it's obviously 0.5. Now, but that was too easy. Now let's do some super problems.
Hold on just a sec, super mathematician. The folks back at home need to learn some vocab before we can complete super problems.
Okay, let's start with the basics. In a sequence, each term is characterized as A1 for the first term, A2 for the second term, A3 for the third term, and etc. AN for any term or a general term. Next, you must check that your sequence is indeed an arithmetic sequence. After you have checked, you can continue. Now take it away.
All the formulas you'll ever need for an arithmetic sequence are AN equals A1 plus N minus 1 times D, which is looking for the nth term. SN equals A1 plus AN times N over 2, which is looking for the nth partial term. The variable N equals the number of terms. Example, the 8th term. A is the common difference, Sn is the sum of the nth term, and An is the nth term.
Thank you for your words of wisdom, nerd. Now let's apply this to pre-calculus. Here we have a problem where a car dealership recorded the number of months they sold cars in. In January they sold 1,350 cars, in February they sold 1,600 cars, and so on. Your first question is, by how much are the car sales increasing by? To find this, you would pick any random month and subtract the month before it. So here you would get 1,600 cars that were sold in February, and you would subtract 1,350 that were sold in January, and your answer would be 250. To prove this, you would have to do it more than once. So you would pick another month, March, where they sold 1,850 cars, and you would subtract the month before it, February, where they sold 1,600 cars. And once again, you would get 250. So the car sales are increasing by 250 every month. There is your first question answered. The next part of the problem says, if the trend continues, how many cars are expected for next year's February? To do this, you will need to use your equations. Here, we would convert January into A1, February into A2, and so on. You will need your equation AN equals A1 plus N minus 1 times D. We found that the difference in cars was 250, so D equals 250. A1 is your first term, which is January, where they sold 1,350 cars. So A1 would equal 1,350. And N is the term you want, and we want next year's February. So that would be 14. If we keep going, we would find that it goes to A14. So we're trying to find A14. Now you just plug in and solve. So A14 equals 1,350 plus 14 minus 1 times 250. This simplifies to 13 times 250. You would just lower this. $13 times 250 is 3,250. You would lower this again. And your final answer would be 4,600. So by next year in February, you're expected to sell 4,600 cars.
The next question in our problem is make an equation for the number of cars sold for any given month. That goes back to the formulas we learned earlier. The formula we're going to use is AN equals A1 plus N minus 1 times D. So let's plug in. A1 is the number of cars sold in January, since that's our first month, which is 1,350. N will be any given term, and D is 250, which is a common difference. And that's our formula. With this formula, we'll be able to find the number of cars sold for any given month. And also, it's the formula we're going to use to solve the next part in our problem. D says, if I wanted to add the cars sold for 2009 and 2010, what would the number be? Okay, so the formula we're going to use to solve this is the nth partial sum, which is Sn equals A1 plus An times n over 2.
Hold on, little nerd. We still don't know what An is, and we need to find that. If we were to continue our pattern that January is A1, February is A2, and etc., we would find that for January's 2010, the A would be A24. So we need to plug A24 in to our original equation to find An. After you find that, we can continue. So go ahead and do that, little nerd.
You're so smart, super mathematician.
Thank you.
According to super mathematician's advice, we need to use A24 and plug it into our original equation. So you just plug in. Our first term is 1,350. Our nth term is 24. We subtract 1, and our common difference is 250. So A24 equals, that simplifies to 23 times 250 plus 1,350. And you get 7,100. Now we have A24, which is our An and our partial sum equation. So then we take this answer and plug it into our equation. So A1 is 1,350. We just found that A24 is 7,100. And we multiply this by 24 over 2. And our partial sum is 101,400, and this is the number of cars sold in the years 2009 and 2010.